Hey everybody, how's it going? Well, in class, you covered the basics of compound inequalities. So what we're going to do in this video is quickly review those basics, but then actually move on to solving our compound inequalities. Right, we covered the basics of and or, intersection and union in class. And what we're going to do is we're really just going to be working on actually applying that knowledge to actually solving the inequalities and then graphing the solutions. Now again, we've talked about this before, but we really need to be working hard in these notes to attempt and try these problems so you know what questions you have. So as we're giving you problems that we expect you to try, we're only going to give you the solutions. So we need to see the work that you're doing on your own to know that you're really working hard and completing these notes. Now that we got that out of the way, let's review the basics here. If we are given a solved compound inequality, meaning that x is already alone, we need to first identify what type of solution set are we dealing with. Are we dealing with an intersection, which comes from our and, or a union, which comes from our or? Well, in this case, it's an and, so we're going to be dealing with the union, right? So we have x is greater than 4 and x is less than or equal to 13. So we graph both of those in the same number line. And what we need to now do is say to ourselves, where are these two graphs of our solutions overlapping or intersecting each other? And we can see the intersection occurs between the 4 and the 13. We can see that's where these two intersections share solutions. Or sorry, these two inequalities share solutions in the intersection. Well, let's look at an or compound inequality. Now we're looking for a union. We're looking for any solution which shows up at all. So we graph x is less than 2 and x is less than negative 5, and we are going to shade where there is any solution, whether it's a solution once or whether it's a solution twice. So that would be everything to the left of 2. If this still doesn't make sense to you, please make sure you write this down and come to class tomorrow to talk about it so we can go over the basics before we move on to the solving. But in this video, we're going to move on right now to solving our compound inequalities, which means we can see in these examples here, the variable is not already alone. So we're going to have to do some work to get the variable alone, and then we're going to be graphing just like we did before. So in these inequalities here, we have a two-step inequality and a one-step inequality. We add 5, divide by 3, and we divide by negative 3 on the right-hand side. Remember, when we divide by negative, got to flip that sign. So we get x is greater than 5 or x is greater than or equal to negative 4. We're looking for a union, all of the solutions which show up, so we can see that we shade everything to the right of negative 4. On B, we're dealing with an and compound inequality here. Again, it's a two-step and a one-step. So we solve both of these. On the left, this time we're dividing by a negative 4. Make sure we remember to flip that inequality sign to get x is less than or equal to negative 7 and x is less than 9. So we're looking for the intersection. Where are the solution sets overlapping? Right here we can see they're overlapping to the left of 7. That's where the numbers are solutions to both inequalities. That's our intersection. Now our last one gets a little more complicated with some parentheses and some like terms, but we know how to deal with these. We've been doing that since we started Unit 2 with our equations. So we're going to distribute on the left, solve our two-step equation. We're going to combine like terms on the right, solve our two-step equation, and we'll get x is less than 9 and x is greater than negative 7. So again, we graph these. We know it's an and. We're looking for an intersection. Where are the solutions overlapping each other? And they overlap in between the negative 7 and the 9. So hopefully, looking at these, you feel confident now with the knowledge we already had from class, along with the skills we already had in solving, about putting these together. But there is a special situation we have to talk about here before we can jump right in and try solving these completely on our own. What happens if we have a compound inequality, but there is no word visibly joining the two inequalities together, such as this example here. Negative 3 is less than 4x plus 5, which is less than or equal to 29. Now this is a compound inequality because there are two inequality symbols in our one inequality statement here. So what do is we have to know that if this is a situation, we always have an and compound inequality. Whenever we don't see a word joining our two inequalities, we can assume that it is an and compound inequality. This means if we are going to have an or compound inequality, we will have to see the word or. But how do we solve this if it's written as one statement here? Well, we do what Bugs Bunny did back in Looney Tunes, and we are going to split our inequality in two. We're going to take the expression that's in the middle of the two inequality symbols, and we're going to split it and use it twice. We're going to use it once with the first inequality symbol and once with the second inequality symbol. And notice the word that I stick in between them to join them together is an and compound inequality. Once we split this inequality into two and write it properly with the word and in there, it's just like every inequality that we've worked with previously. Solve both equations to get x by itself. We have negative 2 is less than x and x is less than or equal to 6. We graph both of these and look for the intersection. And we can see here that we would shade in between negative 2 and 6. So this is what we do if we come across a compound inequality where we don't see a word joining those two inequality symbols. Well, now we're ready. We have everything we need. We have all the skills, all the tools in our tool belt. Let's get right into solving some inequalities on your own. So you've got 4 of them here on this page. I want you to pause the video and please, guys, try these on your own. Ready? Pause. Let's see how we did. So this is what we should have gotten for a solution for each of these compound inequalities here. So go ahead and check, make sure you got that. And then, to graph that solution, we should see that in A, our union gives us all the real numbers here. That's really what's going on. We're shading all the real numbers. In B, we're shading the intersection, which is in between 1 and 9. In C, we have no solutions, right? We can see that these graphs are going away from each other. Where do they intersect? Nowhere. So what are our solutions? No solutions. And our last one here, D, we're looking for any solution that shows up, a union, and it's everything to the right of negative 6. Well, how'd you do? Hope we did well. We got a couple more we'd like you to try here. So again, pause the video and try these on your own now. Okay, let's take a look. We can see these first two compound inequalities are the ones we talked about where we need to split them. So we would need to split them and solve both of them separately, and this is what we should end up with. The one on the bottom, that's an OR compound inequality because we see the word OR. Now that we have our solutions, we can graph them. We can see this is an intersection, so this is an AND compound inequality, so we're looking for the intersection, which is in between negative 8 and 7.5. And on E, this is an intersection as well, but they don't intersect at all, so we have no solutions. The last one on F, again, we can see that these two graphs are going past each other, but we're not looking for the intersection, we're looking for the union. All the solutions which show up, which is every number on the number line, all the real numbers. Well, guys, that's the end. Hopefully you got some good practice solving our compound inequalities. You feel confident about this, and we're ready to come to class and dominate. We'll see you next time.